Hello guys, welcome to today's lesson and I'm your teacher Daniel. Today we are going to look at gradients and equations of straight lines. First, I want us to look at the gradient or the slope, and I want us to consider a construction worker who wants to raise materials to the height of a wall, let's say point B, and for this person to move from this point O to point B, he has to use a ladder. So by moving from point O to B, you should have covered the distance horizontally and also the distance vertically. And therefore you may want to determine the steepness of the distance he has moved both horizontally and vertically, and the ratio of the distance in the vertical height to the ratio of the distance horizontal is what we call the slope, which can be determined using the following formula. That is to say, if you want to find the gradient of this straight line here, we are going to take the distance along the vertical, that is the vertical distance, then we divide by the distance along the horizontal, that is from O to A. That is what we call the horizontal distance. So the vertical distance in this case is represented by a line called Y, and the horizontal distance is represented using or by the line which we call X. In this case, if you look at the distance along the vertical distance, from 0 he has moved upwards 5 units, then we divide by the number of units he has moved in the horizontal direction, which is going to be between 0 and 6. He has simply moved 6 units, and therefore the steepness of that, or the gradient of this ladder, will be equal to 5 out of 6. In short, this is a straight line, and we are going to look at how to get the gradient and the equations of straight lines. I want us to look at an example here. For example, you can be told, find the gradient of a line. Find the gradient of a line. Find the gradient of a line passing through a point C with coordinates 5, 6, and another point D which has coordinates 8, then we have 13 here. So assuming I draw my straight line like this, I find the gradient of a line passing through points C with the coordinates 5, 6, and D with the coordinates 8, 13. In short, if I want to draw my line, although it's not important, but our line passes through a point C with the coordinates 5, 6, and also goes through a point D with the coordinates 8, 13. And we are supposed to find the gradient of this line. How do we find the gradient of a line? The gradient of this line, that is gradient CD, will be equal to change in Y divided by the change in X. That is to say, if this is our X coordinate and this is our Y coordinate, this is also in point D, this is our X and this is our Y, we can call this one X1, then this one becomes our X2, this is Y1, this one becomes our Y2. To find the change in Y, we can take Y2 minus Y1 over the change in X can be determined by taking X2 minus X1. That will give us Y2 is actually 13 minus Y1, which is 6, divided by our X2 is 8 minus our X1, which is 5. If you take 13 minus 6, you'll get 7. Divide by 8 minus 5, you get 3, and that is the gradient of that line CD. Having known how to get the gradient of a straight line, I want us to see how you can get the equation of the same line. So let me give you example number 2 to help us at least know how to calculate the equation of a line. Example 2, that is, before that, let us look at how to find the equation of a line. The equation of a line. Let us take an example here. The question reads, find the equation of a line that passes through, find the equation of a line that passes through, we have 2, 4, and we have 6, 14. So we cannot find the equation of a line without getting its gradient first, and therefore we have to begin by getting the gradient. And we know for us to get the gradient of any straight line, we will always take the change in y coordinates divided by the change in the x coordinates. That is to say, to get the change in the y coordinates, we take the y2, which is 14, minus the y1, which is 4, everything divided by the change in the x coordinate, which is x2, 6, minus x1, which is 2, and that gives us 10 out of 4, which can be simplified using the common factor 2 to give us 5 out of 2. So that is the gradient of that line. But the question is on the equation. How do we get the equation of that line? For us to get the equation of a straight line, what do? We take any of the given points. In this case, let me take 2, 4, and then you take another arbitrary point along that line, which we usually call xy, and that gradient which we have already gotten, to be able to find the equation. For us to be able to find this gradient, how do we find the gradient? You simply ask yourself, to get the gradient is the change in y over change in x, and therefore we take y there, minus the value of y, which is 4, divided by x minus the value of x, which is 2, then this one we equate to 5 over 2. From there we can cross multiply, but I always advise my learners to simply begin with the line that has y. So we take 2, we multiply by y minus 4, which will be equal to 5 times x minus 2. When you open the brackets, we have 2 times y, this one is 2y minus 8, which will be equal to 5 times x is 5x, then 5 times minus 2, this will give you minus 10. The first thing we do, we move this 8 to the other side so that we have 2y is equals to 5x minus 10 plus 8. And this one is going to give us 2y is equals to 5x minus 10 plus 8, you get minus 2. And for us to remain with y, we are going to divide by 2 on both sides. This one and this one goes, and our y is going to be equal to 5 out of 2x minus 1. The reason why we have met the subject is because the equation of a straight line must always be expressed in form of y is equals to mx plus c. So that is, our answer is y is equals to 5 out of 2x minus 1. This is how we express the equation of a straight line. That is to say, the equation of a straight line is always in the form of mx plus c, where m stands for the gradient. And you can see the gradient of this line is 5 over 2, which is reflected in this equation. Then of c is what we call our y-intercept. This is our y-intercept. That is how to get, or how we get the equation of a straight line. I want us to look at other scenarios. because that is when we consider simply a single line. What if you are dealing with two lines which are parallel? What if you are dealing with two lines which are parallel? Assuming we have two lines here, that is line 1 and this is our line 2. Let me say this is line 1 and this is line 2. And you have been given the equation of this line as y is equals to 2x minus, for example, 10. And this one also, its equation has been given as 2x plus even 25. So you already, line 1 has been expressed in form of, y is equals to mx plus c, and our y is going to be equal to 2x minus 10. And then our line 1 will be equal to, again, y is equals to 2x plus 25. If you look at this equation in form of y is equals to mx plus c, the value behind x will always give us the gradient. And also in line 2 here, in line 2, you realize in form of y is equals to mx plus c, it has gradient of 2. If you consider the two lines which are parallel, you realize they have equal gradients. That is to say, if this is line 1, its gradient can be m1 and it is 2. Then line 2, its gradient will be given m2 and you can see it is 2. So if you compare two lines and find out that they have equal gradients, then those two lines must be parallel. That is to say, for parallel lines, m1 will always be equal to m2. That is to say, the gradient of line 1 and the gradient of line 2 for the parallel lines, they will always be equal. Then another thing that you'll be dealing with under this topic, it is two lines again which are perpendicular. Two lines which are perpendicular. And for perpendicular lines, we want to find out what they have in common. That is to say, if we have two lines here, let me say this is line 1 and this is line 2. You realize for perpendicular lines, these two lines will always intersect, making a right angle. Assuming the equation of line 1 has been given as, for example, y is equals to 4x minus 18, and this line 2 has been given, for example, the equation as y is equals to, let me say, negative a quarter x plus even 20. So if you look at line 1, we are able to identify the gradient. The gradient is usually the value behind x, and in this case, our gradient is going to be m1, and our m1 is 4. Then for line 2, its gradient will be given m2, and in this case, our m2 is going to be negative a quarter. For perpendicular lines, if you take the gradient of line 1 times the gradient of line 2, the product will always be equal to 1. That is to say, for perpendicular lines, the product of m1 times m2, the result will always give you negative 1. Another important thing that you need to understand in this topic, apart from getting its gradient, apart from getting the equation of any given line, you need to understand also how to get the midpoints of any given line. Assuming we have a line A, B, and the AB goes through coordinates, for example, 2, 4, and also if it is going through point B, let's say it has, for example, 6, then 14. And you want to find the midpoint. Let me say the midpoint, it is a point where the two, or it's a point that divides that line into two equal parts, and let us give it M. To get the midpoint, this is point A, which is fully described by X and Y coordinate. B also has the x and the y coordinates. Assuming we say this is x1 and this is our y1, this is our x2 and this is our x2 and this is our y1, and you want to find the midpoint of that line, which is the coordinates of M. It is simply the average of the sum of the x values and the average of the sum of the y values. That is to say, to get the coordinates of point M, we are going to take x1, we add our x2, everything divided by 2, then we take y1 plus y2 divided by 2, and that is going to give us the coordinates of M, which is the midpoint of line AB. That is, we have x1 is 2, plus x2 is 6, divided by 2. Then we have y1 is 4, plus our y2, which is 14, divided by 2 again. This one is going to give us 8 divided by 2 is 4. And this is 4 plus 14 is 18, divided by 2 you get 9, and that gives us the coordinates of point M. The last point I may want us to understand again, if you have been given the equation of a line, for example, that is y is equals to 2x minus even plus what, for example 6. And you've been told to find the angle that this line makes with the x-axis. If I may try to sketch it here, assuming this is our line with an equation of y is equals to 2x plus 6, and you've been told this is our y, this is our x, and you want to find the angle this line makes with the x-axis. This is the angle they are looking at. We call it angle theta. And to get the size of angle theta, it is going to be equal to, we give it simply tan theta, which is going to be equal to what? To the gradient of this line, which is the slope. And remember, to get the slope, we take the distance in the vertical distance, divide by the distance along the horizontal, which is going to be equal to the gradient, and the gradient is 2. So to get the theta itself, we are going to get the tan inverse of 2, and whatever you get from the calculator will be the answer. That is tan inverse of 2, it will give you an angle equivalent to 63.43 degrees. And that is the answer in case you've been told to calculate the angle that that line makes with the x-axis. To help us understand these concepts, let me try to summarize what we have done before I give you a question to try and help you understand this topic. The first thing that we have said, number one, it is how to get the gradient of a straight line. And to get the gradient of a straight line, let me say this is like the summary. And number one, we have looked at the gradient. And for us to get the gradient of a straight line, it will always be equal to the change in y over the change in the x coordinates. Number two, we have also looked at how to get the equation of a straight line. And one important thing that you need to understand is that the equation of a straight line is always in the form of y is equals to mx plus c, where m stands for the gradient and the c stands for the y-intercept. Then number three, we have also looked at parallel lines. That is, if two lines are parallel, then their gradients will always be the same. That is, if the gradient of line 1 is m1 and the gradient of line 2, we give it m2, if they are parallel, they will always have the same gradient. Number four, we have looked at perpendicular lines, and we have said for perpendicular lines, if you take the product of m1, you multiply by the product, if you take m1, you multiply by m2, the answer will always be equal to 1. Then, number 5, we have also looked at how to find the midpoints, and for us to get the midpoints, we take x1, we add x2, we divide by 2, then take y1 plus y2, divide by 2, and that will give you the midpoint of any given line. The last one, which we have done, is a case where you have been given the equation of a line, for example 2x plus 6, and you want to find the angle this line makes with the x-axis. We have said if you do it by sketching, this is our line y is equals to 2x plus 6, and you want to find the angle this line makes with the x-axis. This angle is known as angle theta, and for us to be able to get the size of this angle, you take the inverse of the gradient, and that will give you the answer. So for us to know how the various concepts are applied in the question, let us have the question that will summarize on all the 6. The question reads, a line L passes through points -2, 3 and -1, 6 and is perpendicular to a line P at this point, which is the same as this one here. You are required to find the equation of line L, 2 marks. B, you find the equation of line P in this form, that is AX plus BY is equals to C, where A, B, and C are constants. C, given that another line Q is parallel to a line L and passes through point 1, 2, find the X and the Y intercepts of Q, 3 marks. And then the last part of this question is find the point of intersection of lines P and the Q for you to get 3 more marks, which makes it 10. So the first part, let us look at the solution for this question. And we begin with part A. And part A says find the equation of line L. So line L passes through -2 and 3, and it also goes through this point with coordinates -1, 6. We are required to find the equation, but you cannot find the equation without the gradient. And the first thing we are going to do is to get the gradient of the line L. And how do we get the gradient? It is the change in y coordinates. You divide by the change in the x coordinates. That is to say, we can take our y2, which is 6, minus y1, which is 3, divide by x1, which is -1, minus 2, minus gives us a plus, that is plus 2, and this one is going to give us 3 minus 6 minus 3 is 3 over -1 plus 2 is the same as 2 minus 1, which is going to give us 1, and in this case the gradient of line L is 3. We do not need the gradient. We wanted the equation, but you cannot find the equation without the gradient. Now we need the equation of line L. How do we get the equation of a line? We pick any of the 2 points given. That is, I have decided to pick -2, then 3. Even if you pick the other one, the answer will always be the same. Also, I pick another arbitrary point along that line, which we call xy, and that must be able to give me the gradient. Then you ask yourself, how do we get the gradient? It is the change in y over change in y. So we start from unknown, which is y, minus the value of y, which is 3 over x, minus the value of x, which is -2. Minus will give us a plus, and this must give us 3 over 1, which is the same as 3. So from there you cross multiply. 1 times y, you will always get y, then y times -3, you get -3, and this must give you 3 times x, you get 3x, then 3 times +2, you get +6. And remember, the equation of a straight line must always be in form of y is equals to mx. Therefore, to make the y the subject, -3 must go to the other side, so that we have y is equals to 3x plus 6. Then this is a minus. If it crosses the other side, becomes a plus. So our y is going to be equal to 3x plus 9, and that is the equation of L. So the first part has been done, and let us try and work out part B in that particular order. So allow me to rub part A so that I can be able to do part B. And part B, find the equation of line P in form of ax plus by is equals to c. Remember from our first reading, line L and line P are what? Perpendicular. And we said for perpendicular lines, M1 and M2 must give you what? M1 times M2 must give you -1. So what we are going to do, we are going to look at P, and our P goes through a point, -1, 6. What are we supposed to look for? It is the equation. For us to be able to find the equation, we need 2 points, which we are not given. The only thing we have for point P is that point, -1, 6. We also need another arbitrary point, which is xy, but we do not have the gradient. But how do we get now the gradient? We talked about perpendicular lines, and we said for perpendicular lines, if you take M1 times M2, the answer must always give you -1. M1, it is the gradient of L, which is 3. We multiply by M2, which is the gradient of P since they are perpendicular, and this must give us -1. So to get our M2, we divide by 3 on both sides. This one and this one goes, and our M2 is going to be -1/3. So this is the gradient we are going to use to get the equation of line P. So in this case now, let us continue and get the equation. For us to be able to get the equation, take y minus the value of y, which is 6, over x minus -1, which is +1, and this must give us -1/3. So you cross multiply here. So we are going to have 3 times y, you get 3y. Then 3 times -6, you get -18. We go to this other side, -1 times x. This will give us -1x, which is -x. Then -1 times -1, -1 times +1, you are going to get a -1. Then, if you look at this question, we are supposed to write or express our answer in the form of ax plus by is equals to c, meaning the part that contains x must come first. So what we do, we must bring this x to the other side, and if we bring this x, since it's negative, if it crosses the equal sign, it's going to be x. Then of course we add, this is our 3y, this must be equal to, this are the constants, and if we move this to the other side, we are going to have -1, which is there. We take 18 negative, it is going to be a positive, and the answer is going to be x plus 3y is equals to 17, and that is the equation of line P in the form of ax plus by is equals to c. That is the solution for part B. Allow me to take you through question, or part C, that is. Allow me to take you through part C. Allow me to take you through part C. And our part C, we are still talking about the solution of part C. Part C reads, given that another line Q. So we have a line Q here, and the line Q is parallel to L. Q is parallel to L. What do you know about parallel lines? Parallel lines have equal gradient, meaning the gradient of Q and the gradient of L are the same. So line Q passes through point 1, 2. And what they need is what? The x and the y intercepts of Q. We cannot be able to get the x and the y intercepts if we do not have the equation of line Q. And that means we need to get the equation of line Q. Line Q passes through a point 1, 2. We also need to take another arbitrary point along that line. Since Q and L are parallel, the gradient is going to be what? 3. Then we get the equation. So to get the equation, we take y minus the value of y, which is 2 over x, minus the value of x, which is 1, and this must give us 3 out of 1 since this is a fraction. Then we cross multiply. 1 times y, you get y. Then 1 times minus 2, you get minus 2, which is going to give you 3 times x, you get 3x. Then 3 times minus 1, you get minus 3. In form of y is equals to mx plus c. In form of y is equals to mx plus c. We are going to take negative 2 to the other side so that we make y the subject. And our y is going to be 3x minus 3. Then we take this to the other side, we add 2. And our equation is going to be y is equals to 3x, negative 3 plus 2. You are going to get negative 1, and that is the equation of that line. But we need the equation. No. What we need is the x and y intercepts of Q. We know that along the x-axis, the value of y's will always be 0. So we can say at x-intercept, that is along the x-axis, the value of y will always be 0. Y will always be 0. So if we take that equation, where we have y, we put a 0, which is equals to 3x, we minus 1. If we take 1 to the other side, it's going to be positive, and therefore our 3x is going to be 1. And for us to get the x, we are going to divide by 3 on both sides, and our x is going to be a third. So, and we know at y-intercept, the value of x will always be 0. So if we take the equation, our y is 3x, meaning 3 times x, and our x is 0, minus 1, and our y is going to be what? 3 times 0 is 0, minus 1, you get negative 1. So we can be able to conclude that the x-intercept is going to be a third. X-intercept is going to be a third, and the y-intercept will be equal to negative 1, and by so doing you would have solved that question. Anyway, the last part is our part D, and in part D we are supposed to find the point of intersection of lines P and Q. The first thing we need to do is to get the equation of P and also the equation of Q. So again, allow me to wrap this part so that we can be able to use it to answer the remaining part. That is, we need the equation of line P, and the equation of line P was x plus 3y is equals to 17. And then we have Q. The equation of line Q was y. Q, we had y is equals to 3x minus 1, and we can reorganize this so that we bring this to the other side. We are going to have, if we begin with 3x, we have negative 3x, then plus y. This one is going to be equals to negative 1. If we link the two equations, we are going to have x plus 3y, which is 17. This is our equation 1. Then minus 3x plus y is equals to negative 1. If you look at these two equations are simultaneous, and therefore to get the point of the section, which is the value of x and y, we need to use either elimination method, substitution, graphical, and even matrix method. But I prefer we use elimination because it is the easiest. Let us try to eliminate 1. So in this case, what we are going to do, we take the value of y, the coefficient of y there, which is 1, we multiply with the first equation. Then the coefficient of y in the first equation, we multiply with our line 2, so that if you take 1 times everything here, we are going to have x plus 3y, which is going to be equal to 17. Then 3 times negative 3x, it's going to give us minus 9x, plus 3 times y, you get 3y, which is equals to, this times this, you get negative 3. And in so doing now, once we have unified one part, we subtract the 2 equations. We have x minus 9x, we are going to get 10x, which is equals to, because this minus 3x, that will be 0. So we jump to the other side, this 17 minus becomes a plus, and this is 20. So for us to get x, we divide by 10 on both sides. This one and this one goes, and our x is going to be 2. Using that value of 2, we can be able to get our x. So from equation 1, let us substitute the value of x in equation 1. From equation 1, we have x plus 3y is equals to 17, but we have the value of x, and therefore we have 2 plus 3y. This one is going to be 17. If you collect the like terms, 2 goes to the other side, we are going to have 3y is equals to, you take 2 to the other side, you subtract, it's going to give you 15. Divide by 3 on both sides, this and this goes, and our y is going to be 5. So to get the point of intersection, you are going to combine the value of x and y and express them as a pair of coordinates. That is, the point we are looking for will be equal to, the value of x is 2 and the value of y is 5, and that is the point of intersection between lines P and Q. If you have any questions regarding the same topic, you can go to the comment section and send us your questions, and we'll be glad to assist you understand it better. Thank you guys, that is all for today, and make sure you hit the subscription button below, hit the bell so that anytime we do a video like this, you'll automatically be notified. Otherwise, thank you and stay tuned.